Hello guys and welcome at my channel. Today I would like to show you how the first derivative of tangent can be computed by just the first principle only. We've been doing it previously. I've done it once with the quotient rule, but now let's go to basics and let's do it with the first principle. So the idea is we have f of x being equal to tangent of x, and what I'm computing is the first derivative of the tangent just with the first principle. So h towards 0, we have a tangent of xo plus h minus tangent of xo divided over h. All right, so what do we have? Well, we start with the just basic definition of the tangent itself. I don't want to use kind of special formulas, even though I proved them with the tangent of a sum or tangent of a difference, but let's keep it even. So the simplest way we can find to solve it, I'm going to use it. The simplest I know. So we have the sine of xo plus h divided over the cosine. So we have a fraction now, which kind of makes it look maybe a bit more complicated than it should, but just for a short period of time. So we have a sine of xo here, we have cosine of xo there, and we still divide it by h. All right, so now we have two different denominators. We should bring it to the same denominator here. Let's do it. So we're multiplying the first fraction times 1, which we are writing as cosine of xo divided by cosine of xo. And the second fraction is also being multiplied times 1, which we are writing as the cosine of xo plus h divided over cosine of xo plus h. And now, well, let's make it jazzy. So we have limit h towards 0 still. Now we had sine of xo plus h. Now cosine of xo is coming up. Then we had minus cosine. Um, my bad. We had sine of xo only. I just want to keep the same order I had previously. And we multiplied with the cosine of xo plus h. I have to divide it now by the common denominator, which is cosine of xo times cosine of xo plus h. And now we still have to divide the whole fraction. Sorry, the limit is just a bit shifted, but never mind. By h, which I'm writing as h divided by 1. Now you see why I'm doing this, because as you know, division by a fraction means multiplication times its reciprocal. I proved it in one of my videos. I'll link it here. It's in German, but nevertheless, the proofs are without languages and could be understood. So I hope so. So we have the limit h towards 0 still. And now you see this is one of the equations or one of the formulas we proved previously. I think I've done it in my trigonometry list. I'll link it here as well. So we can put it together to sine of xo plus h, which is the first angle. And now because of this minus, it's a minus of xo, which we have here. I can put it this way. So this is the numerator. The denominator is still cosine of xo times cosine of xo plus h. And now we multiply times the reciprocal, which is 1 divided by h. That's great. Now look at this. These two guys are gone. And what we have basically is a limit h towards 0. We have sine of h divided by h, which is kind of familiar, right? We've done it. I'll link it here as well. This is 1. Divided over cosine of xo times cosine of xo plus h. Sorry for the mess. So let's maybe make it clear. We put it apart. So we have sine of h divided by h times the limit h towards 0, 1 divided over cosine of xo times cosine of xo plus h. And I hope that you remember We can only separate those two factors apart if we know that those two limits do exist, and they do. This one is equal to 1. And what about this one? Well, you see, if h is approaching 0, we're just only having cosine of xo, which must exist, otherwise this value wouldn't be allowed. So we have cosine of xo times itself, which is cosine squared of xo. And that's the proof. This is exactly the same result we previously had with the quotient rule. I have to link it again. I hope I'm going to make it. So thanks for watching. I hope it makes sense. Stay tuned. See you soon. Bye bye.